Hello guys and welcome back. In this lecture we are going to discuss about generics in Java. Let us start this lecture. So generics was brought to Java C5 to ensure type safety in Java. So generics is a way of programming in generic programming in which you will pass a type you can pass by type as a parameter to methods and classes and handle them like that. So the generic programming is useful to make our code more efficient and code reusability will be ensured by using the generic programming. Another feature of generic programming is that compile time checking. For example, if you are declaring a generic type string array list, then we will be able to only add string type values into the particular array list. If you try to add a number value or integer value into the particular array list, then it will throw a compile time error. So by using generics, we can achieve compile time checking and type safety. So thank you for watching. Now let us see some programs based on generics. Now let us see a program based on generics. In this program, we will discover the compile time checking of the particular generic type. So here I am declaring an array list in this program. You can see. So after declaring the array list, I am putting only integer values. I am giving the generic type as integer. So like this in angle brackets, I am giving integer, and you can see in the right hand side, I am using the diamond operator, so that I don't need to again define it as integer. So we can use diamond operator. So it will automatically infer the particular type, and after that I am adding a particular value, integer value. So that is fine, and I'm trying to add a double value into the particular integer. So that time it will throw a compile time error. So this is how the compile time safety feature of generics will work. So it will automatically validate our expression, validate our variable, and then it will only allow particular generic type to be inserted. And this is a great feature to have in our program by which compile time only these validations will happen. So we can write more complex code with using generics. So in this lecture we are seeing about generic programming. So generic programming is a concept by which we can pass type as a parameter to methods and classes. So we'll discuss about the generic classes and methods in the next lecture. So thank you for watching this lecture. So I will be back with another lecture. Thank you. Hello and welcome back to another lecture. In this lecture, we will discuss about generic classes and methods. So it's a key concept in Java. So let us discuss about it. We'll start with generic classes. So generic classes are certain classes in which we can uh, we can refer to any type of parameter. So generic classes use a type t parameter so that we can able to infer any types. So that is the goal of the generic classes. So we can write a particular generic code for all the classes which we want to write. So we will see in the practical how these generic classes we will implement. Now let us see the different types of type parameter list which is available for generic classes. So the first one is the T type, and E element, K key, N number, and V value. So that are the different type parameter list values which are provided. So for each one there is a specific meaning we will see in the programs. Now let us see generic methods. So generic methods are certain methods in which we will use the type parameter the parameters to implement the generic concept. And generic methods are you can be static or non-static. Any type of methods can be generic. And one more thing is the scope of the particular argument is within the method scope. So whatever the method is there in that method body scope, the particular type parameter will be valid. So let us see some programs based on generic classes and methods to understand more. Thank you for watching. Now let us see the programs. Now let us see a simple program based on generic programming, generic classes. So in this program, I am going to create a simple generic data structure which can hold any type of values, and we can retrieve the values from the particular data structure. So let us start this program. So here I have a generic class. So here you can see how we will declare a generic class, generic followed by the type parameter in the angle brackets, and after that I am having two methods in the particular class. Each method will infer the type, and you can see the type, it is accessing the type, and add item will add a particular type into the particular um, class, and it is an instance is there to store the particular object and t object. And after that I am having a get method to get the particular item, and you can see the return type is t. So we can provide the return type as t in the generic method, generic class. So let us see the mm, main method to see how this generic class will work. So here is the main method of the program. Here you can see I am creating a generic uh, integer type generic class of that particular generic class, and I'm adding it integer value, and I'm getting the particular integer value. Similarly, I'm doing it for string. I'm creating a string value and adding the string value, and then I'm printing the string value. So generic, if you didn't define a generic class, it can take any type of parameter, even if it is integer or string or anything. We have to write the code like that in the generic class, so that you can see the generic class. You can see in the generic class we can have the type t as a parameter, and then we can write the code according to the type t, and then we can write the accessing code and print adding code into the particular generic class. Now let us see the output of this program. Thank you. So here you can see the output as came. Both integer value and string values are getting printed. So it is able to get the particular integer value from the generic class. So this is our generic class. We can create our own custom generic class. In this class, we are seeing about this implementation of generic class. Now let us see another program about generic methods. Now let us see a program based on generic methods in Java. So in this program we are going to create a generic method which will be used to print all the different types of arrays in Java. So let us start this program. So here you can see I have declared a generic method. So this is the syntax, e followed by the particular display array method name, and in that I am taking the elements, which means arrays will be passed as elements. So I am taking in the e of e square brackets. So to get the particular array elements, and after that I am using the enhanced for loop to go through each elements in the array and print each values. So it will automatically print the particular values present in the particular element. And this is how we will declare a generic method which will print all the values in the particular array. Now let us see the main method to see how I am accessing the particular generic member. And here you can see I have created two types, byte array and a double array, and after that I am calling the same method with a different set of arrays. For double array and byte array I am calling the same method. So here you can see automatically the type will be inferred, and then based on the type it will be executing the loop. So let us see the output of this program. So here you can see the double array and byte array, both the values are getting printed. So that is it for output of this program. In this lecture, we are covered about generic classes and generic methods. So they are used to implement the generic concept in Java, and it can have any type. So other types such as value, key, all the things you can discover by yourself. There are many generic classes which are available in the JDK itself, and we can explore one by one, and it will take a lot of time, but still you need to understand the concept of generics, and it is a very key concept which allow type safety feature in Java. And thank you for watching this lecture. I will be back with the next lecture. Thank you. Hello and welcome back to another lecture. In this lecture, we are going to discuss about wildcards, which is a key concept in generic programming. So let us start. So generic, first we will start with the upper bound wildcards. So wildcards basically are some feature to restrict the particular types. So we can provide restrictions to our types in a particular generic class or method, and we can ensure more type safety by using this feature. So it will provide a upper bound in this case. So upper bound means restriction in the upper level, and we can provide that upper bound by using the question mark symbol followed by the implements for interface extends for class symbol. So like that we can provide the particular restriction to the particular fields, method or fields, variables, or return type, or we can provide the limits. So this is a feature which is used. And now let us discuss about upper unbounded wildcards. So unbounded wildcards are used when we are not sure with the type. So we are not don't know about the type, then we can use the upper bounded unbounded wildcards. So unbounded wildcard symbol, you can see question mark symbol will be there in the middle. We will pass like that, and it is used when we use the functionality of the object class rather than, and it is used also when the generic method doesn't depends upon the type parameter. So at that time also we can use this unbounded wildcards. So now let us discuss about the next type of wildcards, which is a lower bound wildcards. So lower bound wildcards are declared by using the super keyword. So super keyword followed by the particular class. It should be the super of the particular class, like that it should be the relation. Then it will provide a restriction to the particular type. A super relation should be there. So in order that wildcard to work. So this is difficult to understand while in theoretical session. Now let us see some practical programs based on wildcards. Now let us see a program based on wildcards in Java. In this program, we will discover about upper bound wildcards. So we'll start this program. So here the goal of the program is to create a some method which will take the any type of parameter which is a subclass of number. So like that, the relation should be number is a class which is a superclass of the wrapper class double and integer. So that relation should be there. So any subclass of number should be able to work use the sum method. So that is the goal. So let us see this program. So here you can see there is a sum method which I am using the wildcard. Here you can see the parameter list is having the type is is a wildcard type, and here extends number, and that's about how we create an upper bound wildcard. And after that I'm using the double variable to store the particular value, and after that I am using the enhance for loop to iterate through the particular list of list, and then I will aggregate the sum of the particular values one by one, and finally I will return the sum value. And now let us see the main method of this program. So in the main method you can see I am creating two different unmodifiable lists, and then adding particular values, int values and double values, and finally I am calling the sum method for each variables, each list. Now let us see the output of this program. So here we can see the output, sum of the integer values and double values are coming. So that's it about this program on upper bound wildcards. Now let us see another program. Now let us see a program based on unbounded wildcards. So unbounded wildcards are used when we are using the object class methods to access the particular members. So at that time we will use unbounded wildcards. So let us see the code of a simple program in which I will print the particular using unbounded wildcards, I will be printing elements of a particular any type of objects, and we will be having a list. In this list, we will be printing each elements. So let us see the program. So here you can see the display array and list method is there. This method will take the particular wildcard. You can see the wildcard declaration question mark symbol is provided for unbounded wildcard, and after that I am using the using an enhance for loop and iterating through the list, and then I'm printing each element of the list using the object. And now finally you can see the main method. I am declaring the two type of lists, and I'm using the method to call the methods to uh, call the particular list one by one. Here you can see. So that is it about this program. Now let us see the output of this program. So here we can see both the lists are getting printed. So that is about the output of the program. So here in this program we seen about the declaration of unbounded wildcard, and it can be used in the program. So now let us see another program in which I will discuss about lower bound wildcard. Now let us see a program based on lower bound wildcards. So lower bound wildcards are used when we want to restrict the particular type to be of a super type or or its type. So like that we can restrict the type, and let us see the program in which I will be using it to print a particular of a class of an integer and its super type number. So like that the relation types will be allowed. Now let us see the program. So here you can see the print numbers function I have declared in the main method, and it is taking the lower bound wildcard. So the symbol is like question mark symbol followed by the super keyword and followed by the class which you want to make the relationship with an integer. And after that I am using the enhance for loop to iterate through the all the elements in the list and print the values. And after that in the main method I am just using the creating the lists, and then I am calling the print in a display numbers method individually one by one. And then let us see the output of this program. So here you can see it is printing number values and integer values. So this kind of wildcard can restrict the type to be of a type of an this is super. So like that we can restrict. So in this lecture we are covered about wildcards in Java. So wildcards are used to restrict and provide upper bound and lower bound to our generic classes and methods. So it is very helpful to know this feature. Thank you for watching this lecture. I will be back with the next lecture. Thank you. Hello and welcome back to another lecture. In this lecture, we are going to discuss about serialization process in Java. So let us start the discussion. So serialization is a process in which we will convert our Java object into a byte stream so that it will be able to store into the memory. You can store it into a file or database or anything if the particular class is serializable. So how to make a particular class serializable? You just need to implement the serializable interface in order to make the class serializable. Serializable interface is a marker interface, which means that it doesn't have any methods. So marker interface, how it will work is the compiler will identify each marker interface, and based on the name of the interface it will be doing some functionality. Here in this case it will be making that class serializable so that it can be written into the files and all. And now let us discuss about more about serialization. So the reverse process of serialization is called as deserialization, in which a serialized object is converted back to its object form. That is process is called as deserialization. Now let us see more about deserialization. Serialization. So serialization, in case of inheritance, what happens is if a class implements the serializable interface, and then its child cards also will be serializable. So like that it will be. And in case of reference variables, so if a class has a multi reference of another class in its object, and so at that time the reference variables must be serializable. And in case of arrays and collections, all the objects inside we should be serializable in order to complete the serialization process. Next we will discuss is serial version UID, which is a method to find in Java to find out that the both sender and receiver of the object serialization process is having the same class. So to identify that there is a field we have to provide in our serialization class called as serial version UID. So the UIDs of the both sender and receiver should match. Then only the serialization process will complete successfully. So thank you for watching. Now let us see some programs based on serialization procedure in Java. Now in this program, let us discuss about serialization procedure. So serialization is a procedure by which we will convert our objects into byte stream and then store it into a file or any other systems. So let us start this program. So here I have a class which is student class, which I want to serialize the objects of, and this class is implementing the serializable interface, which is a marker interface, which means that I don't need to implement anything. I just need to implement the interface, then automatically it will compiler will identify that this particular class is serializable. And you can see for id name there is no keywords. For branch there is a transient keyword, which means that that particular field will not take part in the serialization procedure. You will see when with the output will come for this program whether it will serialize or not. And I provided a constructor to set the values. So now let us go to the main method where I am serializing the object. So here we are in the main method. So I am creating a file output stream object first, and then I am using the object output stream object, and in the constructor I will pass the file output stream object. So in the file output stream object you can see I am using the out./student.txt, which means I am creating a folder out in the particular Eclipse project main for in the root folder, and then I am keeping away. I want to keep the output file in that particular path. So after that object output stream, I will have the object output stream object, and then I will use the write object method. Inside that I will pass the new object, anonymous object I will create for student, and then I will pass the values. And I am catching the exception file not found exception. Sorry, IO exception. IO exception I am catching. So now let us see the what happens when we run this program. So here you can see it is showing that it is serialized. Now let us see the path where the file is. So I am opening the particular file which is serialized. So here you can see the class. We will not able to understand the code, but it is a file will be created and the serialized object will be saved in that. So now let us see the deserialization procedure. Now let us see the deserialization process. So in this process, the file we are already created a file student.txt in that particular serialized object as came. So now let us deserialize back into a Java object. So here you can see the particular concept. Here you can see the I am using the file input stream object to store the particular input stream which path it should be provided, so that I will be able to read the object. And for the object output stream and object input stream method I am passing the file input stream object and creating the object of the object input stream. Then I am using the student and directly using the object output streams read object method to read the particular object. So that will be reading, and then I am printing each values one by one, each field values one by one. And here you can see the different errors: IO exception, file not found exception, and class not found exception. These three exceptions will be catched, and that's about the deserialization procedure. Now let us see the output. So here you can see the deserialization procedure output. So ID and name is coming, but branch is coming as null because branch is a transient keyword we have used. So it is a not serializable. So it will be null. It will coming. So that's about serialization procedure. So in this lecture we have gone through serialization procedure, which is the procedure of writing the object into byte streams and saving it into files and recovering back. That process is deserialization. So this process we seen how the methods are getting called, we seen. So that's it about the serialization lecture. Thank you for watching. I'll be back with the next lecture. Hello and welcome back to another lecture. In this lecture, we will discuss about externalization in Java. So externalization is a mechanism by which we can customize the serialization mechanism. So serialization we learned in last class. It is a mechanism by which we can convert objects into a serialized byte stream form, and then we can store it in files and all. So externalization is also a similar kind of process by which we can customize the serialization process. So in the last lecture we seen there are some transient keyword which we can use, by which we can customize some of the serialization mechanism. But if it is a large bloated object, at that time it is very difficult to manually add all the transient keyword, and all the manually handling will be difficult. So at that time we can use the externalizable interface, and we can use the externalization process. So in this process there is an interface called as externalizable interface, which we need to implement in our program, and then we need to implement its methods read external and write external, in which we will write our code for what will happen when we object we will write. That part of the code we have to write in the read external and write external methods respectively. And that's it for this lecture. Now let us see some program based on externalization. Now let us see a program based on externalization in Java. So externalization is a process of customizing the serialization mechanism. So let us see a program. So here I will have an employee object, and I will externalize and de-externalize the employee. So that will be the coding. So let us see the particular particular class employee. So here you can see the employee class. It extends the, it implements the a particular externalizable interface, and you can see the method fields in that id, name, and department, and constructor to initialize the values. And after that I will have read external and write external to implement. So in the write external I will implement the writing logic, what I will write to the object when the object is being written into the file. At that time what logic I have to write. So I am only writing two fields into the particular stream, so that I will be customizing the serialization. And after that I'm while reading logic read external method. So there I will write the reading logic, in which I will read only the two elements. For string I need to use the read object method and write object method respectively. Now let us see the main method. So here is the main method. So the first part of the code will be externalizing the code. So here you can see same to serialization. I have to create a file input stream object, and then object input stream object, file output stream object, and then I have to create the file object output stream object. Like that I have to create one by one, and then I have to write object method I have to call, and then I will be able to externalize the particular code. So automatically the externalization will happen on the particular class, and the code will be externalizing. So there are some exceptions which I am catching here. So that is the part of the externalization in Java. Now let us see the de-externalization part of the code. So similar to deserialization, we have to do the file input stream and object input stream with objects we have to create, and then we have to use the read object method to read the particular object, and we have to cast the particular object to our employee class, and then I will print the particular values. And during that process, this process, there are many exceptions which I am catching one by one. Each exceptions are catched. So let us see the output of this program. Here you can see the code is externalizing first, and then de-externalization result is coming for us. So all the de-externalized values are coming. So the department is coming as null because we are not writing the department object. Like we are using the transient keyword. Similar to that, I am customizing the department. Department is avoided. So all other two fields are been printed correctly. So this is about externalization in Java. So it is a process of customizing the serialization mechanism. And in this lecture, we seen about it. Thank you for watching the lecture. I will be back with the next lecture. Hello and welcome to another lecture. In this lecture, we are going to discuss about annotations in Java, which is a very key concept in Java. Let us discuss. So, the first thing to understand about annotations is they provide meta information about our classes, interfaces, or fields or methods. So they will provide us with the meta information. For example, at the rate override, if we put the particular method, that method means that it is overridden from the superclass. So there will be a checking on compile time checking of the particular validation of the condition. So there are several ways these annotations can be used within our programs. And if you work in frameworks and all, then you will understand there are specified annotations for each frameworks, and they will be using annotation to handle the pretty much every code in frameworks. And now let us discuss about some of the annotations which are available in Java by default. So the first one is at override, which we already know. When we override a particular method, we will use the override method, override annotation. And next is that deprecated. So deprecated means it will, if your method is not you want to stop using the particular method, then you can make others stop using the method by making the particular method deprecated. So if you make a method deprecated, then no one else will be able to access, and if they access the method, then they will show get a warning of using while using it. And next is suppressed warnings. So suppressed warnings, how it will work is if there are compile time warnings and you want to escape that warnings and avoid printing the compile time warning messages, so we can use the suppressed warning for annotation for that purpose. Now let us discuss about some more features of annotation. So the must thing is the we can implement our own annotations using custom annotation feature in Java. So custom annotations are those annotations which we define ourselves. So if it's like a class, we can have an annotation, and in that annotation we can define methods in it, and then we can have logic for that particular annotation written over it. And how we will handle annotations is with the help of reflection API and other APIs, we will be able to modify some of the behavior of the objects in real time. By that means we will be able to use the annotation feature. And some of the types of annotations now we want to discuss. So types are, the first one is the marker annotation. So marker annotation, for example, at the rate override, there are no methods on the particular annotation, so it is a marker annotation. And next is then next type of annotation is single valued. So single valued annotations will have single value. There will be only one field to fill the particular annotation. And second type is multi-valued. Third type is multi-valued. So multi-valued means you can have multiple values in that particular annotation. So that's it about some of the basic things about annotation. Now let us see some of the built-in annotation features. So there is an annotation about annotation feature is there. So that is means meta information about our custom annotations will be provided by another annotations, a set of annotations. So one thing to remember again is annotations uh, can store methods which can have default values, and annotations can have these methods in them, and we can use the methods in our program at any place where we are specifying the particular annotation to be present. Now let us see how we can create this built-in annotations. So first one to understand is at target. So it will specify which is the target annotation to be and which is the target annotation. So it will specify which for which element you are going to target your annotation. For example, if it is a class, or if it is an interface, or it is a field, or if it is a method. So like that we can specify each. And one more thing to understand about annotation is annotations. You can have primitive types as well as enums for annotation functions. So annotation methods. And next thing which we need to understand here is at the rate retention. So retention will tell what at what time till what time this annotation feature will work. So if it is a compile time or it's a runtime feature or like that, we can specify it. And the next type is at the rate inherited. So it will mention specify whether a particular annotation can be inherited or not. And finally the at rate documented, so it will specify whether this annotation should be documented in the java doc. So that's all about the annotation concept in java. So now let us see some programs based on annotations. Now let us discuss about a program based on annotations, in this program we are going to create a custom annotations which will provide the meta information about a method. So the purpose of this program is to simulate the particular annotation feature. So annotations can be declared like this at the right interface. So if in your Eclipse or workspace, if you are trying to create annotation, go to right particular package and right click and new annotations. Like that you have to create the annotations. And this will be coming like this at the right interface followed by the annotation name. And in these annotations we can have abstract methods. You can see methods here declared one by one: name, since, and tested, these three values. So you can have also default value which I am providing. And the one thing to notice here is the meta information about annotations. So the retention and target annotations has to be filled so that your annotations will work. Here you can see retention is target is method and retention is runtime. So like that. Now let us go through the main method to see how I am executing this program. So we are in the main method. So here I have can see there is a method how to print say hi method is there, and in that method I am using the annotation. You can see I'm passing in the values. So default value I am not passing, but automatically the default value will be setted, and the other values I am passing name and since. And after that in this method I am not doing anything, just printing a particular value into the console. And after that let us see go to the main method of this program. So in the main method I am using a process called as reflection. So reflection is a process by which we will change the runtime behavior of the object. So here I am trying to access the runtime, whatever the objects has annotations. So the particular of the annotations of the particular object will be fetched. Now let us see how I am accessing. So here I am using the dot class notation to get the class object of the particular annotation. So we will learn about reflection in the next lesson, next lecture. We will explain fully about how reflection is. And for now let us see simply how I am accessing the annotation. So once I get access to the method, I will use the get annotation method to get to the particular annotation class. And after that, once I get a hold of the annotations class, then I will call each method of the particular annotation and print their values. And I will have some exceptions, and I will have no such method exception and other exceptions are there. So we will handle those exceptions by using the catch block. Now let us see the output of this program. So here you can see the values of the annotations are getting printed. So this is how one way of doing the annotation feature. Annotations meta information is provided for the particular method. So here you can see above whatever I declared values, that values have been coming by using the help of reflection API. We are able to fetch those values. And now let us see another program about annotations. Now let us see another program based on annotations. So here we can see in this program I am going to implement a DB column annotation which will mention a particular field based on a field, whether it will be database, whatever the field column will be there. Like that I will mention using this annotation class. And In this program, we will go through all the fields, how we can annotate a particular field and provide the particular values, and how can we access those field values, like that, how we, with the help of reflection, we how we will be able to have access the annotations. So now let us start. So here this is a DB column annotation. So this annotation is declared like this, and the retention policy is declared, and target type is declared. All the values are declared correctly, and after that I am declaring some fields methods in the particular annotation, and after that I have some default value also. And here you can see no default values. I will have some enums to store. Enums can be also used as a type in the particular methods, so we can pass enums. So I created an enum for the type, and I am storing the particular values. And now let us see the main method of this program. So here we can see the main class, in which I will have the logic of having the particular fields DB colon annotation. So here you can see in the student class, I have different fields declared. Each fields I am initializing using the DB. Above the particular field, I have put the DB colon annotation and initializing the values. So like this, you can declare annotations above the fields. So that is possible. Now let us use the main method. So in the main method, you can see this picture. I am using the reflection API similar to the last program we seen how I am accessing the particular fields. Here I am using the get declared fields to access to the particular fields that are present, and then I will use get declared annotations by type method in the reflection API to get to access to the particular annotations. One the zeroth one I will take, so that's why that will get the particular annotation, and I will print all the annotations details one by one. Each field names, field values will be printed here one by one. Each values will be printed. Now let us see the output of this program. So here you can see the output. So all the values are getting populated. The string, whatever the field values which we given in the annotations, has been printed correctly. So this is we can use annotations to fields in this example we have seen. So in this lecture we are going to see about annotations in Java, which is used to provide the meta information about classes. So it will provide all the meta information, such as if we want to give the length. Here in this example we are provided length and the other properties to the particular DB colon annotation. So similarly we can have any set of methods inside annotation, and we can have any different combinations. And that's it about annotations. Thank you for watching this lecture. I'll be back with the next lecture. Thank you. Hello and welcome to another lecture. In this lecture, we will discuss about Reflection API in Java. So let us discuss about Reflection API. So Reflection API is a process by which we will examine or modify the runtime behavior of a class. So if there is a class and we want to know how many fields are there in the particular class, how many methods are there in the particular class, and all other information about the particular class, then we can use the Reflection API. Also, we can invoke methods or inside the particular class using the Reflection API. So Reflection API is widely used in framework design, in IDEs and debuggers. All other fields will use IDEs use Reflection API for code completion, everything. So if a particular method is there, a class is there, then automatically it will import all the methods of the particular class. So that feature is provided due to the help of Reflection API. And another thing to notice about Reflection API is the class is a class which is provided in Java in order to have the access to particular reflection API methods. So there are several methods which are inside the inside the class method. So there are some methods. Let us see some of the methods of the class. So the first one is get name. So get name will get the particular class name of the particular class. Next method is class.forName, so it will return you a class object, and similar to that other methods are there. is interface, is array, is primitive. Similar methods are there. So now let us see some more methods which are there in the reflection API. Here you can see all the methods. So we'll go through some of the methods in the example. So here you can see some more methods. Now let us discuss about the entry points in the reflection API. So reflection APIs has three major entry points through which we will access to the particular reflection APIs. So the first one is using the class.forName method, which is in the static method which is present in the dot class method class, and we will be able to access the particular uh, anything from this point. And next we discuss is next type entry point is using the get class method of the object class. So object class as method we discussed in the object class session that this will be discussing in the reflection API lesson. So get class will return you a class object. By using the class object you will be able to access all other members in the class. Next method is using the dot class method. So the dot class index will allow us to have directly have we can get a class object like that also, and we will be able to modify the runtime, and we will be able to monitor the behavior of the particular class. So this is about reflection API. Now let us see some practical programs based on reflection API. Now let us see a program based on reflection API. In this program, we are going to discuss about the entry points of the reflection APIs. So let us see the program. So here you can see a student class. In the student class, I have a field I, and I have a method test method. So this will be the student object. Now let us see how can I access the class objects of this particular class. So here you can see I am using the first notation is the dot class notation, and that will get me the particular class object. Another form is using the class dot for name method in the class, and next method is using the get class method in the by creating a new object and getting the object get class method. Like that we can access the class objects. So that is a three different ways. Now let us see the output. So here you can see all the classes are printed their names. That's it about the output of this program. So in this program we are seeing about how we can get the entry point to the particular reflection API. Now let us see a program in which we will discuss more about reflection API. Now let us see a program based on reflection API. In this program we will explain about how we can access fields, and how we can access methods using the reflection API. So let us see this program. So here you can see I am using the same student object which I used for in the last example. It has a field n and a name m and a method, and test method is there, and that is about the student class. And here we can see I am using the dot class notation to get to the class object and getting the reflection possible. And after that I am using the get declared fields to get the field array. So all the fields will be returning into the particular array, and after that I'm looping and printing each value, each meta information about the field, and I'm inserting a particular value, and checking the value after all the things I'm doing here. So that's it about fields. So I can access the fields directly using that array and invoking all the methods. Now let us discuss about the method. So method we can directly get declared method functionality is there. So that by using that method we will be able to get the method, and after getting to the method I am printing the meta information of the about the method, and I'm using the invoke to call the particular method. So by using the invoke method inside the reflection API, we can call the particular method. So let us see the output of this program. And before output, let us see some of the exceptions which are occurring, which I need to catch. Here you can see all the different kind of exceptions which is occurring due to the code which we seen above. So that is it about some programs related to reflection API. Now let us see the output of this program. So here we can see each value is getting printed. Now one thing to notice here is here you can see field values are printing and each values are populating correctly, and method is getting invoked. It is calling whatever inside whatever we have written the code for the particular method, it is invoking. So that's it about reflection API. So in this lecture we are seeing about reflection API, which is the ability to modify and examine the read runtime behavior of an object of a class. So that is it about the reflection API. Thank you for watching. I will be back with the next section. Thank you.